Okay, so day 2, talking about inverses. So this is going to be questions from your assignments. So remember, when we're talking about inverses, you have to be able to find the determinant, have a determinant other than 0 for there to be an inverse. If you're going to find the determinants, then it has to be a square matrix, a 2 by 2, a 3 by 3. It's going to be nice and pretty, right? So the first question here I have for you guys today is basically just a checklist of things that make it an inverse matrix, or things that are true about it. So if it's true, you mark it. If you don't, then if it's not true, then you don't mark it. So the first one was a square matrix. The matrices has inverses. Well, a square can have an inverse, but remember, if the determinant is equal to 0, then it doesn't have an inverse. And if that happens, remember, that's what we would call, then the matrix would be called a singular matrix. So that's when you find the determinant and it's 0, then it's a singular matrix because there is no inverse. So the first one's a no. That's not true. A square matrix can have, but it doesn't have to have. So my next question says, if A and B are inverse matrices, so A and B, they are inverses of each other, then A and B must be square. Yeah, absolutely. They have to be square, because in order for us to know their inverses, we need to check that determinant. They have to be square. So very important, and we're working with square matrices. The determinant of a singular matrix is equal to 0. The determinant of a singular matrix is equal to 0. Yeah, absolutely. That's what we just talked about up here. That has to be the case. A and B are inverse matrices, then A plus B is equal to the inverse. No, what operation should we have used there? This should have been multiplication. So it would be A times B, or B times A would be equal to the inverse. Not addition. That is not true for addition. So my next one, if A and B are inverse matrices, so we know that they are inverses, then the determinant of A times the determinant of B cannot be 0. So is that true? Well, we know if they're inverses, then the determinant of A can't be 0, right? It has to be something other than 0. And the determinant of B has to be something other than 0. So as long as I'm not multiplying by 0, I wouldn't get a 0. And that's true. So it has to be some other value other than 0, which means then I wouldn't get 0 here. So that is always going to be a true statement. Any 0 matrix does not have an inverse. When we talk about a 0 matrix, we're talking about all zeros, right? And if I go to find the determinant of this matrix, the determinant of that matrix, the determinant would just be 0, because 0 times 0 is 0, minus a 0 times 0 is going to be 0. So any 0 matrix does not have an inverse. That is true, because the determinant is 0, then it can't have an inverse. Determinant is 0, then there is no inverse. So that is true. If B is equal to A inverse, then A has to be equal to B inverse, and that is absolutely true. That has to be true. That would have to be true. The inverses of them would be equal to each other. So go through them, kind of think them out. Sometimes writing like a counter example helps you guys to see like what are they talking about. Because sometimes with all the words, it gets hard to read them and you're like, I don't even know what it's saying. So kind of try to break it down and draw pictures or see what are things that you know. And so maybe you could kind of counter prove something, or you can show that, yeah, that makes sense, it's true. My next one says, which pairs of the matrices are inverses? So they want to know, are these two inverses of each other? Are these inverses of each other? Or are these inverses of each other? So there's two ways to go about it. First thing is I can multiply them out. So if this is my A and this is my A inverse, then I know A times A inverse has to equal A inverse times my A, which has to equal my identity. So I can multiply them out. I could choose to multiply them out and see, does it equal my identity? So I can multiply them both ways and see if it equals my identity. The other way is if this is my A, then I can solve for that inverse. So if I solve for the inverse, does it make this inverse equation? So there's another way to look at it. Both are correct, both are acceptable. It's just up to you how you want to go about it. So I like to go ahead and I like to take my matrix A here and I want to find the inverse. And if I end up with the inverse is this matrix, then they're inverses, right? So I'm going to solve for the inverse of A. So if I'm going to solve for the inverse of A, first thing I need to do, remember that the inverse of A is 1 over the determinant of A. And then you guys remember this from yesterday where my, I'm trying to think what letters they use, my A and my D switch spots. My B and my C stayed in the same spot, but they took the opposite signs. You guys remember that? Okay, so here's what this is telling me. So this is a review from yesterday, finding the inverse. If I'm going to look at this matrix here, first thing I'm going to do is find the determinant of A. So the determinant of A is going to be 4 times 5, which is 20, minus -1 times 1, which is a -1. So a negative and a negative is going to make this a positive. So my determinant is 21. That means that if I want to figure out this inverse, it's going to be equal to 1 over 21. My A and my D spots, so these two change positions. So my 4 and my 5 switch spots. So this becomes a 5, this becomes a 4. And then my B and my C, I take the opposite sign. So this one will become a -1 and this would become a +1 because I'm switching signs, not because they switch spots. So this becomes my negative. My last step then is this is just a scalar and gets multiplied through. So I know that this is going to go to each and every one of these terms inside here. So the inverse matrix would be 5 over 21, -1 over 21, +1 over 21, and 4 over 21. So the question is, are these two the same? If they're the same, then this is its inverse. But I look here and I realize those are not the same. Definitely not the same. So these are not inverses of each other. The inverse of this equation, the inverse of matrix A would have to be this matrix here. These are not the same. So this would be the inverse of A. This is not going to be the inverse. So I wouldn't check it because it's not true. Going to the next one to check. So again, I'm using the same setup, so I'm not going to rewrite it every time. So first thing I'm going to do is I'm going to figure out what is the determinant. So this is my matrix A that I'm going to be using. So the determinant of this A, actually, I'm going to label it a B just so that I'm not confusing you guys with this A. That's all, the only reason, just to go ahead and not confuse you. So I want to find the determinant of B. So it's going to be 2 times a -4 minus 2 times my 2, and that's going to give me -8 minus 4, which is a -12. So when I go ahead and I find the inverse of this B, then my B inverse is going to be equal to 1 over the determinant of B, which is -12. I switch my A and my D, so this becomes a -4 here and a 2 here. And I take the opposite signs of these 2's. They're both a 2, so they're both just going to end up being a -2. Then I distribute this to each one of these pieces. And when I do that, I end up with a Negative and a negative is going to make this a positive 4/12. This is going to be a positive 2/12. This is going to be a positive 2/12. This is going to be a negative 2/12, which is not simplified. We could clean that up. So that simplifies to a 1/3, a 1/6, a 1/6, and a negative 1/6. And look, you guys, these two equations are the same. They are the same. That means that they are inverses of each other. They're inverses, we can check it. These two are the same. All right, let's do my last one. Are these two going to be inverses? And again, I'll just call this C just to differentiate. You can label a matrix whatever you want, but I need to find the determinant of my matrix C. So the determinant's going to be 3 times a negative 1 is a negative 3 minus 2 times 1, which is my 2. So it's going to be a negative 5. All right, so then I need to find the inverse. So C inverse is going to be 1 over my determinant. So in this case, my determinant was a negative 5, and it's going to be times, and it's going to be my 3 and my negative 1 are going to switch spots. So this is going to be a negative 1 and my 3. And then I'm going to go ahead and I'm going to take the opposite signs of my 1 and my 2. So this is going to be a negative 1 and a negative 2. You guys with me on that? All right. So I go ahead then and I need to make sure that I distribute. So I have, oh, wrong color. My 1/5 goes to each one of these. And some of you guys can already see this isn't going to be the case. This piece matches this right now, right? These two, or almost matches it. This has a negative right here. But if you distribute that through, however you want to kind of look at it. So I already know it's not going to be, because once I distribute this, I'm going to have fractions. But just so you guys know what the inverse is actually going to be, this would be a positive 1/5. This would be a positive 1/5, positive 2/5, and a negative 3/5. So just so you guys have it, and so on. But so yes, these two are not the same. And as soon as I saw that, I already knew I was going to have fractions, so I could have just stopped right there and realized it. Questions on that? Yes, you can multiply them and check to see if you get your identity. In this case, if these identities, because they're all 2 by 2s, your identity matrix here would have been 1, 0, 0, 1. So if you multiplied them both directions, so I would have done this one, this matrix times this matrix, and then I would have needed to done it where this matrix is first times this matrix. So I would need to do both to check it. Now, if one way didn't work, then I wouldn't have to check the other way. It would automatically be done, if that makes sense. Questions? Any questions? None? All right. My next one, I kind of mentioned this yesterday, and this is where we talk about coding. And I didn't feel like they did a very good job kind of laying it out for you guys in the video. This is really nice to have nearby as you're working. I don't know if all the problems have it convenient or not. I feel like some of them that I had saw or that I was working through didn't have the key. And I thought that that was just, it was just helpful to quickly look to figure it out. I don't know if it was on the quiz or what, but I do remember not seeing the key there. Okay, so coding, what does this mean? Okay, so here's their example. Internet sites often ask for a secret phrase to recover lost passwords. Jason encoded a secret phrase using matrix multiplication. He multiplied the clear text code for each letter by this matrix. And when he did that, the matrix he got representing the encoded text is this. Okay, so what is this telling me? What this is saying, and this is going to be how they're all working, is that he takes this matrix C and he multiplied it by the clear code or clear text code. We'll put in a little text code. And when he did that, when he multiplied this matrix by the clear text code, we don't know what that is, he ended up with this encoded text. That's how he got his encoded text. So here's what this is saying. This encoded text, these numbers are representing values. Now these don't match up here. That's because this is the coded piece. It's encoded. It's part of it. Okay, I'll come back to that. I have a question. I will come back to it. Okay, so when I look at this, this is my encoded text. This doesn't help me figure out, well, what is the phrase he's trying to say? What I need to do is I need to figure out what the clear text code is. Now, in order to do that, I want to get rid of this value of C. And the way to get rid of it would be to take the inverse. I mean, we've seen us do this where we it's almost like if we multiply this by the inverse and what I do to one side, I have to do to the other. This would just give you the identity matrix and it would cancel out and it would be gone and it would leave me with just my clear text code. So when I want to find that clear text code, I need to go ahead and I need to multiply that inverse matrix that they gave us, or the inverse of the matrix they gave us, by the encoded, text, by that encoded text. Okay, so first thing I need to do is they gave me the C. I need to find the inverse of that. This is always going to be the case for these when they're looking for that original clear text code. So if I want to find the inverse, I need to figure out then what is the determinant of C going to be. So it's going to be -2 times -1, which is going to be 2, minus 3 times 1, which is 3. So it's going to be a -1. So if I want the inverse here, it's 1 over -1, right? So it's going to be 1 over -1, which is just 1, times, I switch my A and my D, so this becomes a -1, a -2, and both of these are just the opposite signs. So this becomes a -1 and a -3. And then of course I need to multiply that negative to every term. So when we talk about C inverse, it's going to be 1, 1, 3, 2. So if I want to figure out now what the clear text code is so I can figure out what the message is saying, I need to go ahead and I multiply my inverse. So my 1, 1, 3, 2. And I'm going to multiply it by the encoded text. Oops, if I could spell it encoded correctly. That encoded text was -2, 13, -33, -19, 0, -32, -24, -9, 5, 12. My second row is 5, -12, 53, 38, 0, 50, 45, 21, 0, and -12. Oh, a lot, right? That's okay. Here's how this is going to look. It's going to take a little bit of work. You can't plug this into your calculator because in the calculators in Genuity, they only go up to 3 by 3. This has way more columns than that. So I've got to do this by hand, and here's what this is going to look like. I'm going to take my first row and I'm going to multiply it by each one of these columns. So I'm going to end up with, it's going to be 1. I'll write it all out for this. So it's going to be 1 times my negative 2 plus 1 times my 5. Then I'm going to do each one of these. Each one. This is where I'm going through right now. Each one of these columns. So you're going to see me space it out here. So then it's going to be, and there are going to be 1s times each one of these, which should make it really easy. So then my next one is 1 times my 13 plus it was 1 times my negative 12. Do I need to write them? The 1s? No, because you know you're multiplying by 1, but it's good practice. So my next one is going to be 1 times my negative 33 plus 1 times my 53. This next one's going to be 1 times my negative 19 plus 1 times my 38. Then I'm going to have 1 times my 0 plus 1 times my 0. And then I'm going to have 1 times negative 32 plus 1 times my 50. I hope I have enough space. Then I'm going to have 1 times my negative 24 plus 1 times my 45. Oh no, I'm running out of space. And then I'm going to skip the 1s now. It's just going to be negative 9 plus 21. This is just going to be 5 plus 0. And I'm going to squeeze this last one in, and it's going to be 12 plus a negative 12. I'll fix it for the next one. So sorry, it kind of didn't fit. Okay, so my next row then, same idea, but this one I actually have to write all the numbers because this isn't just going to be as clear. And if you want to multiply them as you go through, go for it. But now it's going to be 3 and 2 times each one of these. So it's going to be my 3 times negative 2 plus 2 times 5. This is going to be 3 times 13 plus 2 times negative 12. This is going to be 3 times my negative 33 plus 2 times 53. This is going to be 3 times negative 19 plus 2 times 38. This is going to be just zeros. I don't need to worry about it. It's going to zero out. This is going to be 3 times my negative 32 plus 2 times my 50. This is going to be 3 times negative 24 plus 2 times my 45. This is going to be 3 times my negative 9 and 2 times my 21. And then I have my 3 times my 5 plus my 0. And then my last one, I know it's a mess, 3 times 12 plus a negative 2 times my negative 12. And although you can't read that, those are what this last little piece is. So I need to go through, I need to clean up these values. So this is going to be negative 2 plus 5 is here. Well, negative 2, 5. This is going to be 13 minus 12. This is going to be negative 33 plus 53. This is going to be negative 19 plus 38. This is just going to be 0. Negative 32 plus 50. This is going to end up being, I can't read my own writing here. It's going to be negative 24 plus 45. Then I'm going to have negative 9 plus 21. I'm going to have just a value of 5 here. And this is 12 minus 12. So it's just going to be a 0. My next row is going to be negative 6. So this one takes a little bit more work. Negative 6 plus my 10. This is going to be 39 minus 24. This is going to be negative 99 plus 106. This is going to be negative 57 plus 76. This is going to be my 0. This is negative 96 plus 100. This is negative 72 plus 90. This is going to be negative 27 plus 42. This is just going to be 15. And my last one is 36 minus 24. So I end up now going to just simplify each of these. a 3, 1. This is going to give me 20, 19, 0. This is going to give me 18, 21, 12, 5, and 0. Oh, a lot to take in, right? Okay, next row. This is going to be 4. This is going to be 15. This is going to be 7, 19, 0. This is going to be 4, 18, 15, 15, and 12. Now, if I end up with a negative number, I know I did something wrong because none of them can be negatives. This right here is what the clear text code is. I still don't have my answer though. What is the secret phrase? Well, now all you're going to do is go up here and I could see 3 is a C. So this is my C, this is my A, 20 is T, 19 is an S, 0 is a space. Then so that's my first word is cats, space. My next word, 18, is an R, 21 is U. My next one's an L, E, 0 is a space. My next one is D, R, oh, sorry, D, U. Oh, actually, where's 15? Let me look at D, O, 7 is a G, S, space, D, R, O, O, L. So the secret phrase was cats rule, dogs drool. Totally disagree with that statement, but that's what it is. So that was a lot of work, a lot to go and figure out. It is on your quiz as well to do these. Just so, it's not that it's hard, it's just tedious because you have to go through and multiply them all out. The important piece is that you had to find this inverse before you can multiply it. If you're getting negative numbers here, that's not going to match up with this alphabet piece. Another part of this question, or actually that's it for that question, then I will point out something else. Any questions on this piece, on this encoding? I still have another question to go back to, but in regards to this coding, this coding box, this is the same for all the problems that they give you in regards to matching it up. So that piece is all straightforward. It's just the values of the alphabet in numeric order. Okay, going back to this one, if you were to multiply these, if I was to multiply these to see if it was the identity, I would take my matrix, my 3, 1, 2, negative 1, my 1, negative 1, negative 2, and 3, and I would multiply them together. Oops. So I would do it like this. So when I multiply these, I would multiply that 2. Each of my columns would be 3 times my 1 plus 1 times my negative 2. And then I would do my second column and it'd be 3 times negative 1 plus my 1 times my 3. Then I would do the same thing. And so I would have 2 times my 1 plus plus negative 1 times my negative 2. I'm just going to finish this off really quick. Negative 1 plus this would be negative 1 times my 3. Now, as soon as I do this first one and I get 3 plus a negative 2, I get a value of 1. I'm like, okay, sweet. This is looking good so far. And then I go over here and I have negative 3 plus 3, and that's a 0. It's looking good. And then I do 2 plus a negative 2, which is 0. And then I have negative 2, and I have minus 3, which is a 5. So these 3 were correct. So 1, 0, 0. This had to be a 1, but it's a -5. So it's not going to give me the identity matrix. So I couldn't do it. So as soon as I find one that's a no, the whole thing's out. I don't need to do anything else. My last little piece is it asks you explain why it is important to be able to perform matrix operations by hand when a calculator can do them. So some of your reasoning, so it wants you to explain, and some of these are hard to like just put into words. And so I kind of thought it'd be good just to discuss this because it is one of your questions. So some sample reasons, calculators may not always be available. What if you don't have a calculator with you? You need to know how to do it, right? So these are all reasons. These are all valid reasons on why you need to know how to do it by hand. Finding an inverse by hand allows me to understand the process. So you know how to do it if you could do it by hand versus you just plug it in. You don't know what's going on. Calculators may not show elements of a matrix as fractions. So they may put it as a decimal. And so it might be hard to be able to compare or to see or to understand the data. Sometimes fractions are better than decimals and vice versa. Sometimes it is faster by hand. It's very true. By the time you pull out the calculator, if I wanted to know what is the determinant of this, it's way easier just to do this. Or even the inverse. By the time you type it in and get it all done, sometimes it's just faster. Or a matrix can contain a variable. If it's a variable, if you have an X in it, some unknown or some A, then you can't plug it into the calculator because it can't calculate that unknown. So there's some reasons for that. I just wanted to point them out because again, sometimes when you get those questions and like, what are they looking for and how do you put it into words? So I thought this might be helpful. Any other questions for the day? A lot of information. I will go over another coding tomorrow. But I think this is probably the toughest of them was the coding. And I don't think it's that bad. It's just a lot of work. So if you guys have questions, please reach out to me. And I will see you guys tomorrow. Good luck on your assignment today. All right, we'll see you guys. Take care.